Next problem is a thin uniform rod pivoted at O is rotating in the horizontal plane with constant angular speed omega as shown in the figure. At time t equal to 0, a small insect starts from O, it starts from here, and moves with constant speed v with respect to the rod towards the other end. Okay, so this insect it has started from the point O on the axis, and it keeps on moving with velocity v. This velocity v is constant with respect to the rod. It is going towards the other end. Okay, if it reaches the end of the rod at t equal to capital T and stops, then the angular speed of the system remains omega throughout. The magnitude of the torque on the system about O as a function of time t is best represented by which plot? Okay, so we are given these four different plots. We have to choose which one is the correct, representing the torque with time t. Okay, now let us try to understand the situation. This rod is continuously moving. The insect started from point O. Okay, and as rod moves in angular direction, it keeps rotating. The insect moves from this point to this point. Okay, let us say after time t, it has reached here. Okay, so this distance, or you can say this distance r at time t, can be given by its speed v with respect to the rod and time t. Okay, now since r is increasing linearly with time t, the moment of inertia of insect, which is given by half m r square, that will be equal to half m v square t square. Okay, now the combined moment of inertia of rod will be moment of inertia of rod plus moment of inertia of insect. Now this is not going to change with respect to time. So let us say this is some constant I, and we have half mv square t square. This is combined moment of inertia of insect and rod. Now torque is given by rate of change of angular momentum. Okay, dl by dt. Now dl is given by, L is given by I into omega. Okay, where omega is constant, it is given in the question. So we can write torque as omega di by dt. Okay, now if we differentiate this moment of inertia, I being constant, then we will get omega times half m v square times 2t. Okay, so this will cancel out and we will get tau as equal to m v square omega time t. Okay, now torque is directly proportional to time t, and when t is equal to capital T, the insect stops. Okay, so moment of inertia also becomes constant. So the curve that we are going to get is a linear curve, it's a straight line, and the moment we reach t equal to capital T, then there is no further increase in torque, it comes down to 0. Okay, so the curve is from this point to this point, and then it drops to 0 and then continues parallel to the t-axis. Okay, so let us see which option is correct. Option B is correct. Okay,